This video is on slope and rate of change. I'm going to go down to the end of the booklet and we're actually going to find the slope from real world context. I'm going to open up the booklet and fold it back so that I can focus on just the real world context. We have already learned in previous videos the formulas for slope, so now we can use that in helping us with understanding the real world context. So rate will always have two different units and be expressed using the word per. So you might have heard miles per hour because it's y units. Remember, we need to know the change in y per x units. Per generally means to divide, so it's going to be y units divided by x units, and as slope is change in y divided by change in x. So this still focuses on the y units divided by the x units. So our first example is when Clara was 3, she was 32 inches tall. Now that she is 8, she is 45 inches tall. What is the rate of change in her height each year? Sometimes it's easier to make a table to help us. So let's make a table so we can easily see the changes in the numbers. So in our table, we want to know change in her height each year. Each can be represented with the word per. So it'll be height per year. So again, it's y units per x units. So it's going to be height is our y and year is our x. So when we write out our table, we're going to have our x is going to be our years and our height will be our y's. So let's think about all the years she had and her height. Her first time, she was 3 and she was 32 inches. The second value we have is when she was 8, she was 45 inches. So we can write that as year 3, she was 32 inches tall. When she was 8, she was 45 inches tall. Now let's find the change, our delta y and our delta x. So from 3 to 8, that is plus 5 years. And then from 32 to 45, that is plus 13 years. So the change in y is that 13 inches. So we have 13 inches divided by, for our change in y over our change in x, that's going to be a positive 5 years. So because this is real world context, decimals are always an easier thing to understand than if I said 13 inches every 5 years. So we want to say it as for every 1 year. So if I were to divide this, we would end up getting 2 6/10 or 2.6 inches per year. What does that really mean? So this is our final answer. This is our rate of change each year. So this means that Clara grows 2.6 inches in a year. Or 2.6 inches a year. So this is inches in a year. Todd had 5 gallons of gas in his motorbike. After driving 100 miles, he had 3 gallons left. What is the rate of change of miles per gallon? So again, we have our per, miles per gallon. This is y per x. So we're going to make another table. Our x's are our gallons, and our y's are our miles. So we need to figure out the first values we have. Todd had 5 gallons, and then after driving 100 miles, he had 3 gallons. So we have gallons, we have 5 gallons, but he has not driven any miles yet, so our miles would be 0. Then he has 3 gallons, and he's driven 100 miles. So let's find the change in y and the change in x. Change in x, the gallons, is minus 2. 5 minus 2 gave us 3. But change in miles went from 0 to 100 is adding 100. So this would be change in y is a positive 100 miles divided by the change in x is negative 2 gallons. So if we simplify this, we get 100 divided by negative 2 is negative 50 miles per gallon. So what does this really mean in the context of this problem? Every 50 miles, Todd will lose 1 gallon because this is 50 miles per gallon, 1 gallon. So every 50 miles, he loses, because it's negative, that's why it's losing it, a gallon of gas. The negative can represent either the numerator or the denominator. So the negative 50 could be that positive 50 miles, it's a negative 1 gallon. So 50 miles, he loses 1 gallon. On our next example, in 1998, Linda purchased a house for $144,000. In 2009, the house was worth $245,000. Find the average annual rate of change in dollars per year in the value of the house. So again, we have dollars per year. So y per x. So when we make our table, our x is going to be our year, and then our y value will be our dollars. So our first year was in 1998. And we have $144,000. So 1998, $144,000. Then we have 2009 at $245,000. So 2009 and $245,000. So to find our rate, we went up a positive 11 years. Then with our money, we went up $101,000. So our change in y is for money, $101,000 per 11 years. So if we were to simplify this, and again, it is money and years, we actually want to get to the nearest hundredth because it is money. This would simplify down to roughly $9,181.82 per year. So I have the money in the numerator. Per is division year, because year was in the denominator. So again, what does this mean in the context of this problem? This means that every year, instead of every 11 years, we're talking about every 1 year, the house increases, because this is a positive value, $9,181.82 in value. So the house is appreciating in value. It's becoming worth more, which is awesome. Our last example, it says Marian's computer battery was fully charged at 8 a.m. By 10:30 a.m., her battery was at 65%. On average, by what percent did the battery decrease per hour? So we have battery decrease per hour. So we have y per x. So hours are our x's, and then we have percentage is our y's. So it said that it was fully charged at 8 a.m. So that at hour it's at 8, and percentage would be 100%. But then at 10:30 a.m., her battery was at 65%. So at 10:30, we have at 65%. So from 8 to 10:30, that is plus 2.5 hours. And then from 100 to 65, we are subtracting, or we're going down 35%. So change in y is a negative 35%. per positive 2.5 hours. So again, if we were to simplify this, negative 35 divided by 2.5 gives us negative 14% per hour. So again, in context of the problem, what does this really mean? Per hour means every hour the battery loses 14% of its battery life. So whenever we write an answer, we always want to make sure we understand what it means in the context of the problem, because sometimes answers don't always make sense if you read it back. That's one way you can tell if you're doing the problem correctly, is if the answer truly makes sense in the context of the problem. So always look back and say it in context to make sure it makes sense. And remember, it'll generally be y per x.